How can you add and subtract with decimals? Think about this question during the lesson. Kim and Martin swam 50 meters. Martin took 26 hundredths of a second longer than Kim. What was Martin's time in the race? How long did it take for Kim to finish the race? What operation do you use to find Martin's time in the race? How do you know? It took Kim 50 and 9/10 seconds to finish the race. Use addition to find Martin's time in the race because Martin took longer to finish the race. Find 50 and 9/10 plus 26 hundredths. Estimate first by rounding each addend. Which is the best estimate?
Select your answer.
Estimate 51 plus 3/10 equals 51 and 3/10. Why is it a good idea to estimate first? An estimate helps you to check whether your answer is reasonable. Find the sum. Annex a zero so that each place has a digit. Remember to line up the place values to add or subtract.
Always be precise when working with decimals.
Why is a zero annexed to the hundredths place to make 50 and 9/10 into 50 and 90 hundredths? The zero is added so that the number of decimal places in both addends is the same. You can do this because the numbers 50 and 9/10 and 50 and 90 hundredths have the same value. Add each place. You can regroup the sum of 9/10 and 2/10. Martin swam the race in 51 and 16 hundredths seconds. The sum, 51 and 16 hundredths, is close to the estimate, 51 and 3/10. Now you know how you can add and subtract with decimals.
Suppose that Martin finished the race 47 hundredths second after Kim. What was Martin's time in the race? Use an estimate to check that your answer is reasonable.
I am just going to answer the question. The original time was 50 and 9/10. We're going to add the 47 hundredths of a second to that, and we're going to add 7 and nothing is 7, 9 and 4 is 13. Regroup our 1 plus 0 is a 1, and 5, and then you have your decimal, you bring it down. So remember, when you're adding decimals, they need to line up always, and when you are subtracting the decimals. So Martin's time in the race is 51 and 37 hundredths of a second.
Amy ran a race in 20 and 7/10 seconds. Katie finished the race 258,000 second before Amy. How long did it take Katie to run the race?
We now need to find 20 and 7/10 of a second minus the 258 thousandths of a second for Amy's time before Amy. So Katie now, we figure out her time by subtracting the two. They represent that subtraction in a model, a bar model. So the entire thing represents the amount Amy ran, and then the 258 thousandths is that little slither here that represents the time that Katie finished before Amy. So then we're going to subtract. Here they estimated the 258 thousandths to 0 and 3/10. and subtracted. Now we're going to do the actual subtraction, and so we're finding the difference. Once again, when you are adding or subtracting decimals, you must line up the decimal place. So you have your decimals lined up. As you notice, there are 2 blank spaces here above the 5 and the 8. That's where we need to put our annex zeros. And then to continue to subtract, we must regroup. So we have to regroup the first 0 by making it a 10 so that you can take away 8. And because you regrouped, you took away from the other 0 and made it a 10, but we need to make that a 9 to subtract 5 from 9, and then we must still regroup from the 7 because we are regrouping from nothing with those annex zeros all the way to the 7. So now we had to take away, regroup that 7 to make it a 6. So now we're going to be able to subtract 10 minus 8 is 2. 9 minus 5 is 4. And then 6 minus 2 is 4. And the 20 drops down along with our decimal. And so now the new time for Katie is 20 and 442 thousandths. And that is close to the estimate that they found here.
Suppose that Katie finished the race 1300th second before Amy. What was Katie's time in the race? Use an estimate to check that your answer is reasonable.
So we're going to look at Amy's time again. So Amy's time was 20 and 7/10. And then we have 13th of a second. Katie finished before Amy. So we're going to subtract that. Remember, we are lining up our decimal and we're subtracting. We do need to add that annex 0. I'm going to place it here, and then we need to subtract. But first we have to regroup. So we have to change the 0 to a 10. That 7 becomes a 6. Now we have 10 minus 3 is 7. 6 minus 1 is 5. Drop down our decimal, and we drop down that 20 since there's nothing to subtract it to. So the new time for Katie is 20 and 57 hundredths seconds that she completed that race. Again, it asks us to use estimation to check that our answer is reasonable. I'm going to skip that part.
What is the area of this antique map? Use the formula area equals length times width to find the area of the map.
So we're multiplying the area, the length, and the width. So as you see, when multiplying decimals, they do not have to be lined up. The decimals do not have to be. So we just have our numbers lining up. And then you multiply first your 5s, which is in that ones place, by all of that, and then your 2s. And then you multiply all of that, adding it together, and then you place your decimal. And so the area of the map is 8 and 125,000 feet squared. So let's look at, try it.
How do you determine where to place the decimal point in the product?
So once again, I said with multiplying that you need to have the numbers be lined up. So that is the difference between adding and subtracting with multiplying. The numbers now have to be lined up and not the decimals. So we need to find the answer to where does our decimal point go once we find our product. If you look at the first number, 0 and 43 hundredths, you have 2 numbers after the decimal place. So that means we have 2 decimal places. You look at 0 and 2 tenths, we have 1 number after the decimal, which means we have 1 decimal place. Then you must add those together. We get 3. So our answer or product needs to have the 3 decimal places after the decimal. So we have 0, 8, and 6 that goes after that decimal. And so that is how you know where to place your decimal in the product.